Moving on to a new topic, we'll proceed with the counting techniques. Counting techniques are an important part of combinatorics. These are used for more complicated problems and more difficult sample space or event. The counting techniques include the multiplication rule, permutation, and combination. For counting techniques, we're going to begin with the multiplication rule. If an operation can be performed in n sub 1 ways, and if for each of these a second operation can be performed in n sub 2 ways, then the two operations can be performed in n sub 1 times n sub 2 ways. So let's say, for example, how many sample points are in the sample space when a pair of dice is thrown once? Note that the first die can land in any one of 6 ways. This will be denoted as n sub 1. For each of these 6 ways, the second die can also land in 6 ways. This will be then denoted as n sub 2. Therefore, the pair of dice can land in n sub 1 times n sub 2, equal to 6 times 6, which will be equal to 36 possible ways. There's another type of multiplication rule, which is the generalized multiplication rule. If an operation can be performed in n sub 1 ways, and if for each of these a second operation can be performed in n sub 2 ways, and for each of the first and two, a third operation can be performed in n sub 3 ways, and so forth, then the sequence of k operations can be performed in n sub 1 times n sub 2 until n sub k ways. So let's say, for example, Sam is going to assemble a computer by himself. He has the choice of ordering chips from 2 brands, a hard drive from 4, memory from 3, and an accessory bundle from 5 local stores. In how many different ways can Sam order the parts? So since n sub 1 is equal to 2, which represents the number of brands, n sub 2 is equal to 4, which represents the number of hard drives, n sub 3 is equal to 3, which represents the number of memories, and n sub 4 is equal to 5, which represents the number of accessory bundles, there are therefore n sub 1 times n sub 2 times n sub 3 times n sub 4 ways, equal to 2 times 4 times 3 times 5, equal to 120 ways. Now let's discuss permutation. The number of permutations of subsets of R elements selected from a set of n different elements is NPR, equal to n times n minus 1 times n minus 2 times until n minus r plus 1. Therefore, the general formula for permutation represented by NPR is equal to n factorial all over n minus r factorial. Note that these three notations are equal to each other. So let's say, for example, in how many ways can 7 people be seated on a sofa if there are only 4 seats available? Since n is equal to 7 and r is equal to 4, it will be 7 factorial divided by 7 minus 4 factorial, represented by 7p4. And performing this operation, the number of ways will be 840. There are some special types of permutation, and one of which is the permutation with repetition. Let's define it. The number of permutations of n equal to n sub 1 plus n sub 2 until n sub r objects, of which n sub 1 are of one type, n sub 2 are of second type, and so on, and n sub r are of an r type is n factorial divided by n sub 1 factorial times n sub 2 factorial times n sub 3 factorial, and so on until n sub r factorial. So let's say, for example, how many distinct permutations can be made from the letters of the word infinity? The first step in solving this problem would be counting the number of letters in the word infinity. You will have 8 letters for the word infinity. Then you will have to denote the letters which have repeated. The letter I has been repeated 3 times, and the letter N has been repeated twice. Therefore, applying the concept of permutation with repetition, it will be 8 factorial divided by 3 factorial times 2 factorial, equal to 3,360 distinct permutations. Now the next type of permutation is the ordered partition. This is just somehow similar to permutation with repetition, but it is different in some ways. Let's define it first. The number of ways of partitioning a set of n objects into R cells with n sub 1 elements in the first cell, n sub 2 elements in the second, and so forth is where n sub 1 plus n sub 2 until n sub R is equal to n. So let's say, for example, in how many ways can 7 scientists be assigned to 1 triple and 2 double hotel rooms? So dividing 7 scientists into 3, 2, and 2, you get 7 factorial divided by 3 factorial times 2 factorial times 2 factorial equal to 210 ways. And finally, the last type of permutation is the circular permutation. The number of permutations of n distinct objects arranged in a circle is n minus 1 factorial. So let's say, for example, in how many ways can 5 different trees be planted in a circle? Here, for this example, you let n be equal to 5, so that applying it into the formula of circular permutation, it will be 5 minus 1 factorial equal to 4 factorial equal to 24 ways. And finally, the last type of counting technique is combination. A combination is actually a partition of two cells. The one cell containing the R objects selected, and the other cell containing the n minus R objects that are left. The number of combinations of n distinct objects taken R at a time is n taken R equal to NCR, or the combination of n and R, the general formula of which is n factorial divided by R factorial times n minus R factorial. So let's say, for example, in order to conduct a new experiment, 7 students are randomly selected from a class of 25. How many different groups of 7 students are possible? From this example, you will let n be equal to 25, and you will let R be equal to 7, so that it can be solved as 25 taken 7.